In this video, I am going to discuss about how to convert one octal number to a binary number. In my previous videos, I have discussed about how to convert decimal to binary. So, to convert a octal number to a binary number, we need two steps here. So, what are the two steps? So, one step is convert the octal number to decimal number and then convert the decimal number to binary number. Okay. So, let us start with taking an example without delaying further. So, let us take one octal number, let us say it is 48, base 8 is the octal number, and we have to convert that to a equivalent binary number. How to do that? As I said, first we have to convert the octal number to a decimal number. How to do that? So, this is my octal number, and to convert it to decimal I need to multiply each digit its place value. So, here how many digits are there? So, here there are two digits, so 0 and 1. So, first digit and second digit is 0 and 0th position and 1th position. How to convert that to decimal? So, I have to write 4 into 8 to the power 1 plus 1 into 8 to the power 0. So, whatever base is there, that the power of the base has to be multiplied, and what will be the power? N minus 1 number of digits, or if you start from 0 and then the power you will get which power to take. So, that is equals to 8 for 32 plus 1, that is equals to 33. Okay. So, this is with respect to base 10. Now, this first step is completed. So, in the second step what I had to do? So, the 33 we have to convert that to a binary number. So, how to do that? Already we have discussed about this. You can see the previous videos. You have to consecutively or consequently you have to divide by 3. So, here if I divide, so it will be 16 into 2, that is 32, and the remainder is 1. Then if I divide, it is 8 and the remainder is 0 in this case, and then 2, then it will be 4. So, remainder is again 0. Then it is 2 and this is 1, so this is again 0, and finally this will be 1 and this value is 0. Okay. Now, how to write the decimal equivalent number? So, decimal equivalent will be, we have to write in this direction starting from 1. So, the decimal equation here I will write 1 0 0 0 0 1. So, this will be my this binary equivalent of a given octal number. Now, let us write for another one. So, if I write 10 base 8, what is its value in binary? So, if I have to find this value, then how to find? So, first I will convert this octal number to a decimal number. So, that is equals to, so you have to take 0th position and 1 position again. So, 1 into 8 to the power 1 plus 0 into 8 to the power 0, and the value is equals to 8 into 1, that is 8 here. Okay. So, how we did that? So, the 8 to the power 0 is 1, 0 into multiplied something, it is 0, and then here 1 into 8 power 1 means 1 into 8, that is the value of 8. Now, this 8 I have to convert to binary. How to do that? We just have to do the consecutive division. So, I will take 2, so 4, remainder is 0. If I took 2, then 4, so remainder is 0. I can take as well as 1, and the remainder is equals to 0. Okay. Now, what is the number? So, here the number is 1 0 0 0. Okay. So, the number 10 in decimal in octal is equals to equivalent 1,000,000 in binary. Now, one thing you should notice and remember also, it will be helpful for you. So, the octal number is represented by the digit 0 to 7. Okay. That means 8 digits are there, and it comprises of 0 to 7, all the digits starting from 0 1 2 3 4 5 6 7. And in octal system, if I see the decimal system, then we have a digit 0 to 9 here. So, one thing you should remember that up to 0 to 7, so whatever value is there in octal, the same value will be there if you convert that to decimal. Okay, if I take an example of, let us say 7, right. So, 7 with base 8 is equals to what is in base 10? So, it is 7 into 10 to the power 0, no plus symbol is, no other digit is there. So 7 into 8 power 0, that is equals to 7 into 1, that is equals to 7. That means the 8 power 0 is counted as 1 here. So next, if I take 6, again same thing. So it will be 6 into 10 power 0, and then it will be 6 equals to, not equals to, so 6 is the value in the decimal. So I wanted to put the point here is up to 0 to 7, the octal number can be drawn there, and the octal number 0 to 7 is exactly equals to the decimal number 0 to 7. Now how to remember? In octal number we have inputs like 0, 1, 2, 3, 4, 5, 6 and 7. Okay. I need to represent this in binary. How to represent? So 0 0 0 0 is 0 0 0 0, 4 zeros or 3 zeros you can write. So why I am taking 0 as 0 here? Because the 0 in octal system, it is same as the decimal system. So this number will also be same. Next 1, so 1 is 0 0 0 1. Next is 2, so 0 0 1 0. Next is 3, so 0 0 1 0 0 1 1, right? So like this it can be written, and the last one will be your 111. So 0 1 1 1. Okay. So this is how you can convert the octal number to binary number, and you can remember the simple step here. So this how to get this value also, that I have discussed in the previous classes, like first 0 0, then 0 1, then 1 0, then 1 1. So it should be the order you write the external variable, so that it will be easy and convenient to remember. So in the next video we will be discussing about how to convert a binary number to all other systems. So and then we will be going for your complement, n's complement, r's complement, that we are going to discuss in the next class.